Good morning, everybody, and welcome to the webinar about open data spaces. My name is Mert Gülic, and I'm from the IDSA head office, and I'm responsible for project management. The webinar today will be held by Vincent Bohlen and Fabian Kirstein from Fraunhofer Focus. If you are joining our webinar live today, you can ask your questions afterwards in the Q&A part. We are going to record the webinar and publish it on YouTube, so please like and spread today's outcome. I would suggest that you introduce yourself briefly and then start straight away.
Good morning. Yeah, my name is Fabian Kirstein, and here's also my colleague Vincent Bohlen. We are from the e-government department of Fraunhofer Focus. So we naturally deal with open data, which is an aspect of e-government. And we worked in the industrial data space first and second research project, and we developed there some assets and technologies for publishing open data with IDS technologies. And what we're going to do, is we may have three parts. We make a quick presentation about our concept of open data spaces, and then we have a live demo of our open data connector, and then we have a question and answer section. The first part here is about a small introduction about open data. I will just make it very quickly, so just to get you on track what we are talking about. Open data is highly significant to enhance data-driven businesses, and so especially many IDS use cases. At the moment, open data is mostly published by stakeholders from the public sector and only little by industry stakeholders. But we believe that especially IDS use cases can benefit from integrating public data, so open data, and also publishing open data, for example, traffic data in a digital supply chain. And also we believe that the engagement with open data in the context of IDS can create awareness about open data and leading to a thing we might call industrial open data and also the open data space. And what is open data? Basically, open data describes a concept in which machine readable data can be freely used, reused, and distributed by anyone. And the access to this data is possible at any time without mandatory registration or justification. And this means it is offered free of charge by using an open license. And also this means open data cannot contain any private data or personal data. And the most typical examples here are weather data, geodata, traffic data, statistics, and protocols and judgments, for example. And the motivation here is mostly open data creates transparency. And a good example is data from decision-making processes in politics, where maybe citizens can follow how a certain decision was made and why it was made. And it can be used, processed, refined, and distributed by citizens, non-governmental organizations, universities, and also companies using it as well. And this is why open data maybe contribute to more participation in democracy. And also open data is considered the driver of innovation for economic development, because you can build new application, products, services based on this data. And basically we have two stakeholders in open data. We have the publisher, which usually publish data via a web platform or a data portal. We call it open data portal mostly. And they decide about the terms of use and the data formats. And yeah, the most well-established publisher here is public administrations. But as already mentioned, also other types of publishers do exist. And data users are natural or legal persons who use the data. Most common are data journalists here, but also startups, hobby developers, and governments are using open data. And there are a lot of examples. In the world, there do exist 2,600 open data portals. And some examples from public administration are the city of Bonn has a very good open data portal on a regional level. Then you have GovData, which is the national open data portal of the European Union, of Germany, sorry. And the European Data Portal is the open data portal from the European Union, which gathers all open data from European countries. And some good examples from companies is the open data portal of the Deutsche Bahn, the German train company. They have very good data about their train net. And here in Berlin, we have a very good open data portal about our energy supply company. And the impact, so why are you doing this besides the transparency aspect? One believes that open data holds a high economic potential, actually, because of the new business models you can develop. For example, in vehicle navigation systems, weather forecast platforms, and also in financial services. And there are, you can consider those numbers crazy, or I don't know. But there are studies which predict that by 2020 you have a growth to 75.7 billion euros in the market size of open data in Europe. And actually companies are gaining greater value through transparency, and also openness in general brings greater prosperity. Yeah, and business models, we already mentioned that you can refine open data, that you can enrich your business model, you can sell open data, and so on. And technology, just 2 examples. The most popular technology to build open data platforms is Seeking. It's open source, developed by the Open Knowledge Foundation. You can call it somehow a de facto standard in doing this, because it has a very broad range of extensions. Then you have a proprietary solution from France, Open Data Soft. It's mostly used in France. It's very good, but you need to pay for it. And in North America, very popular is Socrata, which is mostly a cloud-based open data portal, which focuses on visualizations for the published data. And then you have a lot of standard and specifications. Just briefly here, you have, it's well known, also used in the IDS, is DCAT, a W3C recommendation. We have in Europe an extension of that, especially for public sector data sets, which is called DCAT AP. Also, European thing is Inspire. It's a big spatial information infrastructure. It's not only a specification, there are a lot of assets here, software assets. And also by the Open Knowledge Foundation, you have a cool thing which is called frictionless data. It's a description language for describing semantically tabular data. And you also for sure have a lot of barriers. Political barriers are there because decision makers usually have a low priority in pushing open data. In organizations, you have issues because it's not an integral part of the processes. You have legal issues. Users are unclear about what they can do. Can they publish data? Is it private data, and so on. Also, opening data costs money, so you need to invest in that. And still, there's a huge technical barrier, especially regarding data quality, interoperability, and so on. So this was just a small introduction to open data in general. And now we move on to what we believe IDS and open data have in common. Mostly 2 things. We believe open data is an enabler for the IDS because it can lower entry barriers for applying IDS specifications and technologies. Because at the moment, you have a lot of good IDS concepts and use cases, a lot of companies are involved, but still most of those implementations are closed. And so if we would create open components, which can be used with open data and also other data, it can be an enabler for the IDS. And so it's not just a use case, it offers an easy access to exchange data in the international data spaces. And also, if we deal with open data, we completely, at the moment, remove legal issues here. We can just set up an open data ecosystem or data ecosystem. We don't have to worry about usage control. We can just straightforward implement it. So it is, it will be a good showcase for the IDS. And also investing, if companies in the IDS invest in open data and use those components, they move towards new business models because they think about publishing open data and so on. And on the other hand, it's using open data in the IDS. For sure, if you build data-driven applications, you might want to use open data. Those are just 3 common examples here. You have the digital supply chain. So data about traffic allows transport partners to efficiently plan delivery routes. We have a lot of smart mobility, smart urban use cases in the mobility sector. Logistics also can benefit from traffic data, and also people, human citizens can benefit here from open traffic data to effectively plan private routes. Actually, in the IDS, some things were done already about open data. There's, for example, one member of the foundation, Advaneo, which is who is offering a marketplace, also including open data. There's a vertical, the urban data space, which also includes concepts of a proactive provision of data. And we here did develop a couple of years ago a first version of an open data connector, which allows to publish open data from a CCAN backend. We believe IDS is a good open data technology because although industrial data spaces or international data spaces address different problems, they still share a lot of things because basically both of them are metadata repositories to spread information about available participants and data. And we have 2 core differences. Usually in open data, we apply pull mechanisms. So open data ecosystems gather data from different sources. In IDS, the basic idea is to have push mechanisms. So the data provider may just advertise the data they have. And we compared this here in more detail. We have 6 dimensions. And openness, IDS is, we already mentioned, the industrial components are mostly closed, but the essential part, the information model, is open. It's an open standard. You can just use it. And data sources is basically the same. You have open data portals which gather data from the publisher, and the broker in the IDS performs somehow a similar task, just make available what data is available. And data storage is different here a little bit. In open data, we already mentioned the data is harvested. In broker, with the broker, you have a more push approach. And the standardization is also very similar. IDS also uses DCAT. Open data uses DCAT and DCAT AP. So you have a good interoperability here. And data integration is an interesting point. If you move the technologies from industry and open data together, you have it much more easier to integrate data from both worlds. And then we have trust. Although in open data, trust is not that an issue, it would improve open data also if you add this IDS trust layer, a bit of certification here. So, just to sum up here, we do believe open data and IDS are a perfect match, and the IDS architecture can be used to overcome some essential barriers and enable the industry to become an open data user and provider. And in the next step, my colleague Vincent will explain some more technical details what we are going to build.
Okay, so now in part 3 of this presentation, we will talk more about the vision we have for the open data ecosystem in the industrial data space or in the international data spaces. So while thinking and while designing the ecosystem, we thought about the different users or roles that people will take in this ecosystem. So as a first step, we have, of course, the data steward, the person who is responsible in a company, in a public administration or wherever to publish the data and who already has access to data in public or internal data management systems and has now the desire to publish those openly. As a second user, we have the administrator, who is responsible for setting up the connector or the ecosystem, and is then responsible for helping the data steward performing his desired tasks. As a third step, we have a provider-side developer, mainly responsible for developing new systems or components to further to make the life of the data steward easier. So that means especially hooking up not natively supported data management systems to the Open Data Connector. Then there is, on the other side, we have a data user. That is someone that is consuming the open data. That could be another IDS participant that is using an IDS connector to consume the data, or it could be a user who is using the Open Data Broker's user interface to query the data in a human readable and human accessible form. And on the last part, there's a consumer side developer. That is a person who wants to programmatically query data from different open data connectors or data stewards, and who needs to be able to query the metadata and then decide which data he actually wants to consume. More on the technical or even theoretical parts, there's the IDS artifacts we applied in constructing the IDS open data ecosystem. Of course, there is the information model. The information model in the IDS is used to define the components and the communication between each components in the ecosystem. The information model is mainly used to transport the information about available data assets from a connector to a broker, who will then make this data accessible. Then, of course, there's a connector. A connector is the role, takes the role of a data provider in the open data ecosystem. That means that each entity that is providing data will have its own instance of one of those connector, or one instance or more multiple instances of a connector to grant access to their data to the public. Okay, then there are data apps. In the Open Data Connector, data apps are used to communicate between the data management systems and the actual connector, so that a connector is able to publish data that is stored in multiple data management systems or others. Yeah. So, as well, open as well as proprietary data sources can be connected by implementing one of those adapter apps. And lastly, there's the broker. And the broker takes the part of an open data portal in the ecosystem. So there is a UI which will display the metadata of the data that is published by connectors. So here are some examples of data sources that can be integrated with the data connector, or in fact, those are the data sources we plan to natively support with the connector implementation we provide. So there's on the one hand, there's a Postgres database solution. Then there's just simple file uploads, so a user can upload a file and then make it available via the connector. But then there are more public standardized sources such as CCAN, or even proprietary solutions such as Eurostat or the geodata repository of the German Weather Association, the DWD. Okay. Now let's go further into the architecture. As you can see in the middle, there are the two main components, the connector and the broker. or the Open Data Connector and the Open Data Broker. The Open Data Connector has on the left multiple data sources which it is connecting via different adapter apps. Then it has a storage component which stores the metadata of the data sources available, or the data assets stored in those data sources. And then there is of course, the IDS self-description, which is sent to the broker to make the data available, or the metadata about the data available to the public. The broker, on the other hand, also has, of course, a storage unit which stores the information sent by the connector, as well as a user interface via which data consumers can access the data in a human-readable form and perform search operations and generally search for the data they want to access. Also, there will be an API, and the API's job is to enable the broker to be operated by an existing open data portal to integrate the data that is published from inside the IDS to the outside world. So, for example, as we heard, the European Data Portal could operate an open data broker and then integrate the data from the open data broker into their search mechanism front end. Of course, the consumer is able to query data from the connector directly, either via another connector or by thoroughly studying the shape description of the connector. Okay, now to get into more technological view. To comply with the IDS reference architecture, we implemented the connector as a microservice architecture. That means that all components of a open data connector are implemented as web services and provide their functionality via REST endpoints. To ensure component isolation, all those web services are encapsulated inside of Docker containers and therefore living in their own isolated environments. We use Docker Compose to provide easy configuration and build processes, and to provide extensibility of the Docker, of the Open Data Connector, we provide an Open API specification, which depicts how to implement an adapter app to be able to add non-supported data management systems. All right. Right now, the Open Data Connector's source code is available at GitHub. Each component has its own individual repository, and if you want to take a look at it, the URL is written down there, and the main repository, or the entry point for all the other repositories, is the IDS -open -data -connector repository. And if you have a look at it, you will see that there are backend, front-end, adapter components, and all the other repositories resemble one of those component parts. Okay. Now a little bit about the certification. The Open Data ecosystem aims to be certified as IDS-based security profile. We aim to apply for an IDS-ready assessment in the certification scheme, and that means that the base security profile will be reviewed, or the concepts of those requirements will be reviewed. So some of those are basic access control, secure communication, authentication mainly between connector and broker, and isolation of software components. Okay, so right now, what is released and what is available to the public is an open data connector under as work in progress. And in the next few months, we will release, or we will release an open data broker implementation, and will provide more adapters for proprietary data management systems, namely the Eurostat and DVD geodata, which I already talked about. So, some takeaways of this presentation. We think that open data and the international data spaces will accelerate each other by increasing the amount of data that is shared. On the one hand, the data that is shared in the IDS infrastructure, and on the other hand, they may increase the overall amount of open data published. We found out that the core mechanisms of IDS and the mechanisms of open data match perfectly, so IDS is a suitable match for building open data ecosystems. One of the benefits of the open data ecosystem is that data providers actively push the data offerings. This, on the one hand, ensures that quality and accessibility in open data portals is increased, as well as the data sovereignty of the data publisher is ensured by not passively being harvested, but actively pushing the data offerings. So, and of course, the IDS open data ecosystem will act as a transparent implementation of the IDS artifacts, representing an entry point for potential IDS providers. So, and now we will do a short or a live demo of the current open data connector implementation. So we'll start by having a look at the repository that I already mentioned. So as you can see, we have a Docker Compose file here, and we have setup and startup files here. How this is used is explained in the README file over here. So you mainly use the setup shell script to boot to set up all the other repositories and then boot up the connector. So now we'll switch to the connector front end, and here you can see the administration panel of the open data connector. So we can log in as an administrator. And the first step that we will take here now is to configure the open data connector. So we will give it a title, let's say open data connector focus here. And then we will provide a connector URL, which is the URL that the connector will later be reachable from the outside. So this could be ids.focus.de. And as a maintainer, we could again add focus.fraunhofer.de and a curator. All those fields are necessary to build the connector self-description because this information will be used there. So now we looked at the configuration, and we can have a look at the self-description document here. So this is a JSON file made up of two parts. This one is just general information about the connector, and then here we have the actual base connector information. So we have a title. This is the one I entered just before. We have the maintainer and the curator here, and then we have the access URL over here. As you can see, right now the connector does not provide any data offerings or data requests and offerings, but we will change that now. So as the first part, we have the option to start and stop adapter apps. That means adapters to data management systems. Right now on this machine, there are adapters for CCAN and for Postgres installed. We are free to start and stop those adapters with these buttons. What is happening in the background is that a Docker container is now stopped, or another Docker container is started up with the actual adapter implementation inside. Okay, so we will now add a data asset. We can we now add a CCAN data source so that the connector will be able to query this data source for other data assets. So in our case, we have a CCAN, a demo CCAN running here in-house with some sample open data datasets we will now publish. So in order to register this data source, we will give it a name. Let's call it IDS backend here, and then add the API URL for the CCAN and a port. So we will click on data source hinzufügen, and now we have a now this connector is aware of the adapter. So let's go back to the CCAN, and we can see that we have a lot of open data sets here. So we may choose to publish the train station information by the German railway company. So if we click here, we will see the information. And actually, to query all relevant metadata from a CCAN instance, the only thing that you need is the resource URI. So we take this resource URI. You can see this is the data set of the train station data, and we will add it here. So as you can see now, this job is being processed, and if we click on data assets now, we see that the data asset we wanted to connect is now actually processed by the adapter and available for display on this side. So we can now, for now, let's do something like this. If we look at the connector implementation, we still see that the catalog is empty. But if we now choose to publish this data asset, we just edit. The connector self-description will have been updated, and we can now see that the catalog holds another data resource. And this is the one we actually just added. We have here the title of the data asset, Stationsdaten Deutsche Bahn. We have the holder of this data asset, the Deutsche Bahn, and we have a description of the holder. And most importantly, we have information about the endpoint. Here it is. We have the resource endpoint, and we can now see that the host is what we just edited in the configuration part of the connector. We have a path that is /data, and we have a file name, which is right now the internal ID, and we can now query this data by combining the information we get from the service endpoint. And in fact, what will then happen is we will click here, and in fact, this is the location where this data can be downloaded. So we have this multi-part message with the connector description, set description response here, and the actual data down here. Okay, so what else we can do? We could also add a Postgres database, and as you can see, there's different information necessary to register a Postgres database. So The Seeker was available. The Seeker API is available via REST endpoint and the URL, and you only need the resource ID to identify your data asset. But in a Postgres database, it's a little more complicated. So what we will do now, we add another database. So what I will do now is we have a database running in the Docker environment, and we will just use that as an example here. We will query the job data that is located in the Docker database. So we have the URL here, we have a port here, and then we add a database. We need a database name, and then again we need the username and we need a password to access this database. So let's add this data source, and now you can see while in the CCAN, for the CCAN it was sufficient to only specify the resource ID. For Docker you need some more information. You need, on the one hand, you need an SQL query. As you see, I will query all the information that is in a table, in a job table in the database I just registered. And in CCAN, we are able to query the metadata from the underlying CCAN instance. But for Postgres, for a database, you have to specify your metadata as well. So let's give it a title. Let's say job listing. And some description. The list of all the currently available jobs in the database. All right, let's add this one as well. And as you can see, we have a new data asset right here. It has a name and it has a description. And if we want to download this data asset now, what is actually happening is that the query is performed just in time. So we will always get different data sets according to what is actually in the database right now. So let's have another look. And as you can see, you will get the multi-part message. Let's do it. Let's see. Okay. So we get a multi-part message again. On the one hand, this is the actual data. I will go to that later. And then we have the self-description response that we already got for the CCAN, but we will get it again here. So there it is. So this is the data we got from the database. So as you can see, we created 2 jobs. And this is just the one we just created. So we have the query that I entered with the dataset nodes, and we have the dataset title. So that's pretty much it. So for the data asset handling. So we can now again publish this data, and the connector self-description will update. So right here we have this, we have the job listing, and we have what is of course not filled in right now is the sovereign and just other metadata that could be queried from the CCAN, but can of course not be queried by a Postgres adapter. So one last thing about the brokers. We are able to register a broker over here. So what is happening here is that when you register a broker, let's just assume there is a broker at focus.fraunhofer.de running. You register the broker, and what is happening is that the connector is now sending a connector subscription message to the broker or the service specified by this URL. You can now could as well unregister from this broker, so it will send an unregistration message to that broker. Further, whenever you publish or unpublish one of those data assets, the updated connector self-description will be sent via a connector update message to that broker. And now that is the first glance for the Open Data Connector.
And one important thing, it's open source actually, it's Apache 2 license. We move now our development work also on GitHub. We before developed it internally, and yeah, we encourage every reuse and feedback. And if you use it, we are the only ones at the moment who are using it, so there may be problems in getting it started. So just use the GitHub issue tracker of the main repository, which is pinned in GitHub, and yeah, we try to together to get it stable. Yes.
Yes. Let's give some sources again. Switch back to the presentation. Yeah, we have again the link to the GitHub repository and the link to the position paper that we talked about with the same name, Open Data Spaces, that was really published in March or February of this year. So that was that. Thank you very much, and let's go to the question and answer section.
Yeah, thank you both for the high quality information. I think especially the live demo was really helpful. And then I would suggest to go to the Q&A part, as you said. If there are any questions, please ask. Yeah, I will handle it to you now. So I guess there are no questions, but we will upload this webinar on YouTube, and please spread the word. And if you have any questions, please comment on the video. I would like to thank you both for your time and content, and thank you.
Yeah, you're welcome.
Yeah.
Thank you.
Thank you very much.
And also thanks to everyone for attending, and see you next time.